Hi everybody, welcome to another video in Math 1332, section 5.1, number theory, prime and composite numbers. So number theory, is the primary concern with the property of the counting numbers called the natural numbers. The natural numbers is the set of all the counting number 1, 2, 3, 4, 5, and so on. Natural numbers that are multiplied together are called factors of the resulting product. For example, if we have the product of 24, we might have 2 and 12 are factors, 3 and 8 are factors of 24. Right. Next, we define divisibility. If A and B are natural numbers, A is divisible by B, or if the remainder is 0, so remainder equal to 0. If it is divisible, we say B is a divisor of A, or B divides A. Simple, B divides A. So which one actually the simple for that? Well, this one is true because 5 divides 15 divisible by 5. So because it is 15 divided by 5 is 3 and remainder 0, so that's one true. Actually anything we divide by 0 except for 0, so 0 divisible by 10, so that's one is good, it's true as well. This is not, 3 is not divisible by 12 and 4 is not divisible by 13. Right. Next we have prime factorization. A prime number is the natural number is greater than 1. So first of all, it's greater than 1 and has only 1 itself and 1 as factors. Composite number, again, is greater than 1. So 1 is considered middle, that is divisible by a number other than 1 in itself. So if it is greater than 1, it is not prime, then it will be a composite number, right? So divisible by a number other than 1 in itself. So prime only divisible by 1 in itself. Composite will be more than 1 in itself. Every composite number can be expressed as a product of prime number in one and only one way. So every composite number can be expressed as a product of prime numbers in one way only. Right, we'll see that in a minute. For that, I just want to quickly go to this. This is the method to find all the prime numbers. So we start with the basics, the prime number, the small one. So 2 is the prime number, and then 3, 5, and 7, because 2 is only divisible by 1 in itself. So is 3, so is 5, and so is 7. So what we do is we will cross out all the multiple, I should say, and then all the multiple of those, but we're not going to cross those numbers itself because those are prime. So we're going to cross all the multiple of 2 except for 2. So cross out 4, 6, 8, 10, 12, 14, 16, 18. So pretty much all the multiple of 2, not counting the 2 itself. Now cross out all the multiple of 3, not counting the 3. So not crossing the 3, but now 6, 9, 12, 15, 18, 21, 24, 27, 30, 3, 6, 9, 2, 5, 8, 2, 1, 4, 7, 60, 3, 6, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, and 99. Right. Now the next one is 5 is a prime number, so we cross out all the multiple of 5. Actually, I'm just going to cross it like this because those are the multiple of 5. And then cross out all the 7. All the multiple of 7 except for 7. So 14, 21, 28, 35, 42, 7 to 49, 56, 63, 70, 77, 84, 91, and then the remaining are primes. Right. Now, so when we try to find the prime factorization, remember the factorization of prime numbers is unique, so there's only one number. So when we do this is we just find the factors of 700. It is tempted to say 7 times 100, but the rule of this is we start with the smallest number possible, start with 2. That 350 still divisible by 2, and that will be 175. And now we don't, this number is not even, so it's not divisible by 2 anymore. Try 3. Right, so no, how about 5? Yes, and 35. 35 is 5 and 7. So 700 is equal to 2 times 2 times 5 times 5 times 7. But we will write as 2 square, 5 square, and 7. So this is a unique prime factorization of 700. Right, next 84. 84 divisible by 2, 42, 2, 21, 3, and 7. So 84, 2 square, times 3 times 7. So that's 84. Next we have greatest common divisor, or some books call the greatest common factor. To find the greatest common divisor of 2 or more numbers, first find the prime factorization of every number. That's easy. Next, select the prime factor that is smallest exponent common to each of the prime factorization. So you choose the common factor to the least power, right? And the pairs number that have 1 as the greatest common factor is called, that pair of numbers are called relatively prime. Right, next we have the example that 5 and 26 are relatively prime because the greatest common divisor of them is 1. Alright, 216 and 234. Let's do that by hand. 216 divided by 2 is 108. Divided by 2 is 54. 2 is 27. 3 and 9. 3 and 3. Right. That's 216. 234. 2. 117. Certainly it's not divisible by 2, but how about 3? Yes. And then 3 again, 13, and 13 is prime. So the factorization of 216 is 1, 2, 3 of the 2, and 3 of the 3. 234, 2 times 3 square times 13. Then the greatest common divisor or greatest common factor. We'll find the common factor of each one of them. So there's a 2 on both of them, and there's a 3 on both of them. However, we choose the one that goes with the lowest power. This by default is 1, so we have to choose the smallest one. It's 1. 2 and 3, we choose a smaller number. So that's why we have 2 times 3 square, which is 18. So that is the greatest common factor. We'll find the common factor of each and then raise to the lowest power. Right. Next we have the least common multiple. So least common multiple, the way we find that is still do prime factorization. But this time we select every prime factor to the greatest power. So that to contrast with the greatest common divisor. This time we choose every factor but with the highest power. Then multiply all of those numbers, we have the least common multiple. Right. Find the least common multiple of 114 and 300. 144, sorry, is 2 and 72. Be 2 and 36. 2 and 18. 2 and 9. 9, 3 and 3. Right, so that's 144. 300. Was it easy to say that is 3 times 100, but I advise to go with the smaller number possible. And now 2 doesn't work anymore. 3 be 5 and 5. So 144. 1, 2, 3, 4. And 3 square. Then 300. 1, 2. Then a 3 and a 5 square. So this is the least common multiple. So the rule says we'll write out every factor. Here's a factor of 2, factor of 3, and factor of 5. The 2 square. Now we choose every factor but to the highest power. So that's what we have. Because we would multiply all of this out. So it's to the highest power, right? So this be 4. Yeah, the least we choose our greatest, those that 3600. Right. And what happened? We have 3 numbers. What the rule is still the same. First, find the greatest common divisor of 108, 84, and 60. 108, do the prime factoring first. 54, 2 and 27, 3 and 9, 3 and 3. Now break out 84, 2 and 42, 2 and 21, 3 and 7, 60, 2 and 30, 2 and 15, 3 and 5. Right, so we write down 108, 2 square, 3 cube. 2 over 2, 3 over 3, 84, 2, 2, 3, and 7, and 60, 2, 2, 3, and 5. So this, I said, for every problem, just go ahead and do prime factoring, and then we pay attention later. So greatest common divisor, or the greatest common factor, we're going to choose every common factor, 2 and 3. Now all of them have the second power. We choose the one with the least power, and 3 here, choose the one with the least power. So with that we have 12. Right? Choose a common factor of everything to the least power. By default it is raised to 1. Right. Now find the least common multiple 12, 18, and 21. So 12, 2 and 6, 2 and 3, 18, 2 and 9, 3 and 3. Right? 21, 3 and 7. That's pretty much it. Right, let's write down 12, 2 square times 3, 18, 2 times 3 square, and 21, 3 times 7. Now, this time we want the least common multiple. So we're going to choose every factor, but to the highest power. In this case, both of them are 2. To 52. Right, so it's not that bad. So greatest common divisor. For the greatest, we choose the one with the least exponent, least power. And for the least common multiple, for the least, we actually choose the greatest. So kind of backward. And the greatest common divisor, or the greatest common factor, we choose the common factor. And the least common multiple, we choose every factors. Now we have some application problems. Movie theaters run each film continuously. One movie runs for 80 minutes, the other one 120 minutes. Both movies begin at 4 p.m. When will the movie begin at the same time again? So if we think about this, let's say this is 80 minutes, and that is not, and both of them start 4 p.m. So, and then 20 minutes, so that's a little bit longer, So we just find eventually they catch up at the same time, and the question asks what would be that time. So in that case, remember the last example we said it doesn't matter greatest common factor or the least common multiple. Just gonna do the prime factoring first. Two and 40, 2 and 20, 2 and 10, 2 and 5, and then 120, 2 and 60, 2 and 30, 2 and 15, 3 and 5. So we say 80, 1, 2, 3, 4, and 120, 2 cube, a 3 and a 5. Now, so regardless, we're going to do the prime factoring. Now the question is, how do we find the greatest common divisor or the least common multiple? Well, think about this. The way we stack it up, we actually stacking the movies together. We actually not breaking up the 80 minutes into blocks, right? So if that is the case, that is the multiple. if we stacking them together, we're not breaking them up, so we're not finding the factors, we find the multiples. So we find the least common multiple. There's a factor of 2 to the highest power. There's a factor of 3 and a factor of 5 to the first. That's 240. So that will take 240, and in terms of minutes, that will be 4 hours. Right? So instead of 4 p.m. we're going to plus 4 hours to it. So the question is, when will the movie begin? The same time again. That will be in 240 minutes, or in 4 hours. That will be 8 p.m. So 4 p.m. and then add 240 minutes from that, and we have 8 p.m. 4 hours after 4 p.m. Right. Next, an enterprising college student get the deal on slightly past their prime packet of instant coffee at the chain of coffee store. He acquired 200 packets of decaf and 280 of regular coffee. The plan is to package them to sell. Of course, he's not going to sell all 200 decafs and 280 regular coffee at the same time. He will break them up into package. And the question is, how can do this? Each box contains the largest number of packets. So when we see the largest or the greatest, we know it have to be greatest common factor, right? Or greatest common divisor. Also, another clue for this is, of course, if we break them up, it could be factors. And the way it works is, we try to find the box that contains the sum of the package in it. Of course, the bigger the box, in this case they said the bigger the box the better, but regardless, we start with the prime factoring. Right, so we have that, and then 200 to 100 to 50 to 25, 5 and 5. So we say 280, 1, 2, 3 times 5 times 7, 200, 1, 2, 3, 5 square. Right. Now largest, so that means the greatest common divisor. So we take every common factor, the common factor of 2, both them to third power, so we choose the least of those, which is 3, and then the 5 and 5 square, we choose the common factor of 5 and the least power 1. So that gives us 8 times 5, which is 40. So if we break things up, it's going to be the greatest common factors. Breaking up meaning factors. If we don't break it up, we stack them. That means the least common multiple. Right. Next, have you ever noticed that many hot dogs come in a packet of 10, but most hot dog buns come in a packet of 8? Well, the point here of that is usually when you buy it, you have 2 extra hot dogs, and that's like they force you to buy the extra 2 when you don't need. But let's say you don't want that, and you just find the smallest number of packets you can buy, so that they have the same number of hot dogs and buns. So my question is, do we break up a packet of hot dog or the packet of buns? The answer is no, we're not breaking them up. So more likely it's not greatest common divisor, It's not greatest common factor. So in fact, this time we stack together. Like if we put 10 packets of hot dogs and then 8 packets of buns, if the numbers match, then that would be ideal, right? So regardless, what do we do first? The prime factoring of 10 and 8. So 10 is 2 times 5, 8, 2 cubed. Now, again, we do not break the package. We buy a bunch of packets so that we have the same number of buns as hot dogs. So that means we don't stack them up. We don't break them up. So that is not common divisor. We actually stack them up. So that will be the least common multiple. We choose every factor of 2, every factor of 5, and to the highest power. So 8 times 5, 40. So we need to have 40 buns and 40 hot dogs, meaning 4 packets of hot dogs and 5 packets of 8 buns. Right. With that, we finish section 5.1. As always, thank you for watching and see you in another video in Math 1332.